in factoring was to be able to solve quadratic equations, because quadratic equations are a little bit different from linear equations. Linear equations have one solution. We're able to solve them. We don't have to do anything special. But then when we throw in that squared term, it kind of messes things up. Now, let's talk about this for just a second before we actually get into the paper that I have there for you. We have three scenarios when it comes to solutions to quadratic equations. Most of the time, we have two real solutions. Your parabola is going to cross the x-axis twice, whether it's facing upward or facing downward. Most of the time, our parabolas are going to cross the x-axis twice. So we have two solutions. Those solutions may also be called roots. They may also be called x-intercepts. They may also be called zeros. Those are all the same thing. Okay, solutions, roots, x-intercepts, zeros, those are all referring to the same thing. Where your function crosses the x-axis, so that's where the equation equals 0. So what x value makes this equation equal 0? Sometimes we have a special case. We talked about this with factoring. Perfect square trinomials put us in the position where our parabola just touches the x-axis. It just touches it. It doesn't cross it twice. It just touches it in one place. And in that case, we have one real solution. And I mentioned this, I believe, last week, that we call that a repeated root. We call that a repeated root when it just touches once, because we get the same answer twice. We get the same answer twice. So, for example, this could be x plus 4 squared. We touch at -4 because -4 would make that equal 0. Okay? So we've got two solutions. We've got one solution. And then our last scenario is that we may have no solution. It may not touch the x-axis at all. And in that case, we have what we call imaginary solutions. So I'm letting people write this down really quickly, and then I'll scroll down to the third scenario. So quadratic equations, x squared, degree 2, we expect two solutions, but it is possible to have two real solutions, only one real solution, but it's technically two because it's repeated. And then, I don't want to rush anybody here. We can have the case where it doesn't cross the x-axis at all. So I drew two of them on here. Okay, those are two separate parabolas. But neither one of those cross the x-axis. So we don't have any real solutions. There are no real numbers that would make these equations equal 0. But we do have two imaginary or complex solutions. They always come in pairs. We'll deal with the complex solutions later on this week. Right now, we're just going to focus on the two real solutions and the one real solution. But if it doesn't cross the x-axis, you've got imaginary or complex solutions, and you have to rely on your calculator to help you out with those. You can't use the calculator. Okay. With the first two scenarios, you can graph those. You can graph them and find the zeros, and you're going to get the answer. With this one, it doesn't cross the x-axis. You don't have a 0. You can't use the calculator to graph them and find the answer. So you're going to have to use what we learn later on this week. Okay? So, just wanted to give you that little bit of an overview before we actually got into solving some of these equations. So, if you didn't get the factoring so far, we've got another opportunity to work on that factoring, because that's what we're getting ready to do to solve some of these equations. We're going to start with equations that are factorable and find their solution. Okay? All right. So these are coming off the worksheet that everybody should have. I put it in the middle of your table. So to solve by factoring, the number one requirement is that your equation must be equal to 0 before you can factor. I repeat, it must be equal to 0 before you can factor. So that doesn't bother us on number 1 because our equation is already equal to 0. But after this point, we're going to have to make sure that it's equal to 0 before we jump into factoring. Okay? So let's look at number 1. It is k squared minus 14k plus 49. I started with a pretty easy one just to get our feet wet. Okay, let's see here. The 49 is positive, so that means I have the same signs. And the first term, the 14, is negative, so that means they are both minus signs. What multiplies to give me 49 and adds to give me 14? 7 and 7. Okay, so like I said, this was an easy one. I wanted us to get into it slowly. Okay, it's equal to 0. Okay, this is an equation now. We didn't have an equal to before because those were just expressions. It's an equation now, so it's equal to 0. Somebody wake up Gabe, please. So we're going to set both of these equal to 0. We're going to set both of these equal to 0, and I know they're the same thing. Okay, I realize that, but I'm just trying to prove a point. And we're going to solve them for the variable. So to get k by itself, I got to add 7 to the other side. I do that for both of these. So k equals 7. This is the case of one solution. This is a repeated root. This is a repeated root. K equals 7 is the answer, and it is a repeated root. So technically, you don't have to write it twice. Now, just to show you that you can always check this on the calculator, I'm going to throw it in y equals really quickly, and I'm going to show you how this looks on the graph. Okay, there's the parabola. It touches, and it's over there at 7. You can confirm it. You can go to the table, find x equals 7. The y value is 0. Okay, so there you go. That's how that repeated root shows up. All right, let's look at number 2. X squared plus 6x plus 14 equals 6. It must be equal to 0 before we start factoring, so we've got to move this 6 to the other side, so we have to subtract it from the right side. It's a constant, so it's subtracted from the constant on the left side. So really what we're going to be factoring is x squared plus 6x plus 8. 14 minus 6 is 8. So, what are we looking at here? 4 and 2, positive and positive. The 8 is positive, the 6 is positive. So we've got 4 and 2. So we set x plus 4 equal to 0 and x plus 2 equal to 0. So we subtract 4 from both sides for the first one. So we get negative 4 is one of our solutions. We subtract 2 from both sides in the other one. So negative 2 is our other solution. Now, I'm not going to graph this one, but I am going to plug it back in to check. Anytime you're solving an equation, there's no reason not to plug it back into the original equation to check it. Now, the only thing we have to be careful with here is we've got negative answers. So we have to put parentheses around them. So we've got negative 4 squared plus 6 times negative 4. You can use parentheses or you can use your times button, plus 14. And that should give us 6. It does. And I can press second enter, and it brings up that last thing that I put in. So I can change my negative 4s to negative 2s and make sure that that also gives me 6. Okay? I plugged it into the left side and made sure that it equaled the right side. Easy, easy way to check it. And if we think about it, multiple choice, answer choices, plug them in. If you don't remember how to do it, just plug them in. Okay, let's look at number 3. Number 3 looks a little weird. Okay, my suggestion on number 3 is to move everything to the left side. I know that means moving 2 terms, but I don't like dealing with negative quadratic terms. Okay, I don't like when the negative is in front of the squared term. So I'm going to do whatever I can to get rid of that without having to deal with the GCF. So that means I'm going to add 42, and I'm going to add 6m squared to both sides. And I'm going to write it in standard form. Okay, I'm going to make sure that I write it in standard form. So my quadratic term comes first, 6m squared. I moved it, so now it's positive because I moved it across the equal sign, it changed signs. I didn't move the 48m, so it's still minus 48m. And I moved the 42, so it's positive 42. Okay, so our rules of factoring are still the same. The first thing that we should look for is GCF. Yeah, 6. All those are divisible by 6. So take out the 6. Nope, yes. 6 times 8 is 48. So we've got m squared minus 8m plus 7. Okay, so we've got a minus and a plus, so that means that the signs are the same and they're both negative. And 7 times 1 is 7. 7 plus 1 is 8. Now, I take each factor and I set it equal to 0. So 6 is equal to 0. Is that true? No. 6 is not equal to 0. So I'm going to throw that one out. But I still write it down because if that had been a GCF of 6m, 6m can equal 0, right? If m is 0, 6 times 0 is 0. So I want you to be in the habit of copying that down, even though we know that 6 is not equal to 0. Okay, so 6 is not equal to 0. M minus 7 is equal to 0. M minus 1 is equal to 0. We add 7, so we get positive 7. We add 1, we get positive 1. Those are our 2 solutions. Now, if I was going to check them in this case, I got to plug them into both sides of the equation. So I got to plug in 7, so I get, let me clear this out so you don't get confused. Negative 48 times 7, okay, I get that answer. Now I got to type in the right side and see if I get the same number. Okay, negative 42 minus 6 times 7 squared, I get the same number. The left side equals the right side, so I'm good to go. Okay, 7 works. I'm going to assume that 1 works if 7 worked. All right, number 4. Number 4. N squared plus 13n minus 14 is equal to 8n. Again, got to be equal to 0. That 8n, it's got to move. So I've got some like terms here. It's positive over there, so I subtract it from both sides. So 13 minus 8 is 5. So we've got n squared plus 5n minus 14 is equal to 0. We've got 14 is negative, so that means we have opposite signs, 1 plus, 1 minus. The 5 is positive, so that means the bigger number gets the positive. So 7 and 2, positive 7, negative 2. N plus 7 is equal to 0, n minus 2 is equal to 0. Now I realize some of you can do this in fewer steps, and that is fine. Okay, but I want to write out as much as I can for the benefit of most of you. Okay, so I realize some of you could probably skip from this step right here to the answer. You could probably go from there to the answer, and if you can do that consistently and correctly, I have no problem with that. But Most of you kind of need to see it to get to the correct answer, so I'm going to keep doing it. All right, one more, and then I'm going to turn you loose on these. Number 5. Okay, 42a squared is equal to 9 minus 7a squared. So it's got to be equal to 0. And I've got like terms on both sides. So remember what I said about not liking my quadratic terms to be negative? So I'm going to add that 7a squared over here. I'm going to do this one in 2 steps because I don't have much room. So I'm going to write 49a squared is equal to 9. And then I'll move the 9 to the left side because it has to be equal to 0 to solve. Okay, now I'm going to factor it. What do we call that? Anybody remember that name? Difference of perfect squares. Difference of perfect squares because we have 2 of them. There's a minus sign. Okay, difference of perfect squares. So, difference of perfect squares. 49 is a perfect square. 7 squared is 49. So we've got 7a and 7a. 9 is a perfect square. So we've got 3 and 3. What are my signs? 1 plus, 1 minus, right? Okay, so 7a plus 3 is equal to 0. We haven't dealt with one this complicated yet. This is a 2-step linear equation. It's not really that complicated, but it does take an extra step. We subtract the 3 first, so 7a is equal to negative 3. Then we divide by 7. So a is equal to negative 3 over 7. For the other one, we add 3 to both sides, so 7a is equal to 3. We divide by 7, so this one's almost the same thing, but it's positive. So you may see it written like this. You may see them write a is equal to plus or minus 3/7. That just means that both the positive and the negative work out. Okay, both the positive and the negative work out. Also be careful if you check a fraction that if you square it, you put parentheses around it just like you would a negative number. Okay, so 42 times 3 over 7 squared and 9 minus 7 times 3 over 7 squared. We get the exact same number for the left side and the right side. So 3 over 7 checks that. Okay? So that is solving by factoring. Most of the time, your answers are going to be whole numbers. Most of the time. But it is possible to get some fractions as well for your answers. It is possible to get fractions for your answers. Okay.